All right, so in our last video, we were talking about taking logarithmic expressions and making them into exponential expressions. And the main takeaway from that is you're going to have a base. In this case, it's a b, and this base is being raised to the y power. It's being raised to the y power. So y is going to be the exponent, and then the x on the other side is going to be the result that you get. Now we can take this exponential expression and make it into a logarithmic expression. That logarithmic expression is going to have a base of b. That's that small number down there. The exponent is going to be on the other side of the equal sign. That's the exponent. And then the result that we get is going to be inside the parentheses. That's going to be our result. So we can use these rules to go back and forth. We can go from exponential to logarithmic, or like we're doing today, we can go from logarithmic back to exponential. So let's look at number 1. This one says logarithm base 3 of 81 is equal to 4. So what I'm going to do first is I'm going to circle the base. The base is always going to be that small number under the g. That's going to be the base of our logarithm. So when we write our expression, 3 is going to be the base for the exponent to go off of. The exponent is going to be on the other side. In this case, it's a 4. And I get 3 to the 4th power is equal to 81. That's the result. That was the number inside of the parentheses. So 3 to the 4th power is equal to 81. And what that just means is if you have 4 3s being multiplied together, 3 times 3 times 3 times 3, you're going to still get 81. So that's 3 to the 4th power. All right, so moving on to the next one, notice that I have a base of 2. So that's going to be brought down first. That's my base. My exponent is going to be a 3. That's over here on the other side. So that's going to be the exponent. And then whatever's inside the parentheses, we're going to bring that down last. And in this case, it's going to be 8. So 2 cubed is equal to 8. That's just 2 times 2 times 2. And that's equal to 8. Okay, so 2 cubed equals 8. That's called my exponential expression. So we're going from logarithmic to exponential. Let's look at number 3. For number 3, what is my base? My base is going to be 7 this time. And what we're going to be doing is we're going to be taking that 7 and raising it to the exponent of -2. So 7 to the -2 power is equal to 1 over 49. So what that's just saying is if you have 7 and you raise it to a negative power, that negative power is going to turn into a positive power in the denominator. So the way that works is you're going to have 1 on top, but on the bottom of the fraction, you're going to have your base of 7 raised to the +2, and that's going to give you 1 over 49. So the last one we're going to do is number 4. Notice that we don't have a base for this, but that's just because it's the natural logarithm. The base is always going to be e. So we can rewrite this as log base e of e is equal to 1. Notice that the 1 stays the same. Notice that the e on the inside of the parentheses stays the same. The only difference is we change the natural log to the log of base e, which is equivalent, right? Natural logarithm always has base e. So now what I can do is I can make this into an exponential expression. So what's my base? I always start off with the base, right? That's going to be e. My exponent over here is a 1. I'm going to put that on top of the e. And then on the other side of the equal sign, I'm going to have whatever my result is. And in this case, it's an e. So does that make sense to you? E to the 1 power is equal to e. That's what it means to take something to the first power, right? whatever it is just stays the same. So base E just stays E. Okay, so that's logarithmic to exponential, and I hope that helps.